you guys agree that 1 is equal to the square root of 1 squared, right? Agree? I mean, surely no one disagrees with that just yet. But you also agree that that 1 squared is the same as -1 times -1, right? Right? -1 times -1 is still 1, right? Okay, so this is the square root of -1 times the square root of -1, right? Because that's a property we had for square roots, right? The square root of a product is the product of the square roots. But the square root of -1 squared is what? Well, it's -1, isn't it? What? This is why we can't just use the properties of radicals and exponents on negative things. It opens Pandora's box in terms of, like, there are ways of understanding this. How did I get 1 equals -1, right? It's this step right here is totally bogus. The square root of AB is not equal to the square root of A times the square root of B. When... Uh-huh. Well, -1 times -1 is equal to 1, which is equal to 1 squared. I mean, I'm just pointing out you can trade the 1 squared for -1 times -1. The 1 squared step isn't even really necessary, right? I mean, you just say 1 is equal to -1 times -1. Well, anyway, my point to you, the reason that this fails in terms of our thinking is that we've never said that the square root of A times B is the square root of A times the square root of B when A and B are negative. Right? And the reason we don't say that is because if we did, then we'd have to address this issue. The way this is actually addressed is the following. 1 to the 1/2 power is actually equal to -1 and 1. And 1 to the 1/2 is not equal to the square root of 1. When you deal with higher mathematics, we make a distinction between the 1/2 power and the square root. So the 1/2 power has all possible square roots. The third root, like the 1/3 power, has actually 3 things in it. The 1/4 power has 4 things in it. The 1/5 power has 5 things in it. When you take the 1/6 power of a complex number, it's got 6 things in it. But the square root always is just one thing. The cube root is always just one thing. The 4th root is just one thing. These are the so-called principal nth roots. If you study complex math, you learn these things. So that's the resolution to this, is like these are both 1/2, they're both quote-unquote square roots of 1 in that sense. But anyway, do we want to get into this? We do not want to get into this, right? So that's why it's important to assume positive bases when we're making all these simplifications like I did today, all right? Just warning you. Anyway, I think that's it for today, so thanks, guys. If I haven't given you your quiz back, you can get it from me.